Again, 1.1 is all about being able to describe graphs with some new vocabulary that you've probably never seen before. Some of it you will have seen before in previous courses. Some of it is new. Let's start things right off right away. A function is a mathematical relation that maps a set of input values to a set of output values such that each input value is mapped to exactly one output value. This is the mathematical definition of a function. In previous courses, you probably would have said the x's do not repeat, or it passes the vertical line test. All those things are true, but it's not sufficient enough anymore for this class to use those definitions for a function. We need to get more technical with how we describe it. In fact, there are some functions we're going to study in this class in Unit 3 that wouldn't pass a vertical line test, but are actually functions. So we need to get better at that vocabulary. Let's highlight this sentence right here. We're going to do this in just general yellow. We will use the statement, each input has exactly one output when explaining why a given relation is a function. So each input has exactly one output is the mathematical way I want you to talk about it instead of saying the x's do not repeat or passes the vertical line test. Speaking of inputs and outputs, which is how I want you to describe the x's and the y's now as inputs and outputs. Instead of input values of a function, you've called it the domain for a long time, and that is its name. The domain of a function is the set of input values represented by that independent variable, which for the most part is x. It's the one that we're plugging into something. The independent input is your domain. The set of output values of a function is called the range, and it's represented by the dependent variable, which we usually represent as y or f of x. That vocabulary should all be the same, including the next little bit of vocabulary. A function itself is positive when the graph of f lies above the x-axis, i.e., for example, the outputs or y values are greater than 0. So if you're looking at a graph and the outputs are what I would consider above ground, if the x-axis is the ground, those are positive values of f. Vice versa, a function of f is negative when the graph of f lies below the x-axis, aka the outputs or y values are less than 0. This sounds very straightforward, and it is, but because of what I'm about to introduce in the next little section, we have to make sure we know what I'm talking about here. When I'm saying the function is positive, I mean the outputs are positive. When the function is negative, that means the outputs are negative. This is very important that you understand the difference in how I'm saying that because of what I'm about to introduce to you in this chart below. What really gets different about pre-cal is what we are doing is we're going to describe the graphical behavior function using pretty much these 4 terms. The first 2 are really simple, and we're going to do pink for this one. Just kidding, we're going to do green for this one. An increasing function, or the part of a function that's increasing, is when the output values always increase. So if you see this linear equation right here is increasing. Don't overthink it. The slope is positive, right? So we have a positive slope. Okay, that's what we would have looked at in a linear equation, is a positive slope. It's increasing. The rate of change is positive. A decreasing function, this is the one we're doing in pink. A decreasing function, as the input values increase, the output values always decrease. So again, we see this little sad going down line that would have a negative slope. Does that feel okay? Increasing and decreasing. Really not different, makes sense. Goes up, goes down. Increasing, decreasing. What gets complicated about this is we will now add 2 more vocabulary words for our curvy functions. The vocabulary word concave up, which I'm doing in blue. Concave up is a portion of a graph where not that the graph is increasing, but the rate of change is increasing. So this polynomial right here, this quadratic that's like a happy little parabola, is a concave up function. And since I'm telling you that that means the rate of change is increasing, I want to pause and make sure we understand what that means. Because even though this side of the graph, and I'm pointing here to this side right here, since this side is going down, this is a decreasing portion of the graph, but the entire thing has a slope that's going up. Because if I were to make a secant line at all points, or a tangent line, this is going from being super negative to less negative to less negative to less negative, and all of a sudden we're getting positive. So that whole time the number representing the slope or the rate of change is getting bigger, going from super small negative, getting bigger, getting bigger, getting bigger, until we're positive and it looks like it's actually increasing. Similarly, a concave down function, this one's purple, concave down is the opposite. The rate of change is always going to be decreasing in a concave down portion of a function. This sad parabola is concave down because its rate of change is decreasing. As we go along here, any tangent line would be very positive, getting smaller, getting smaller, getting smaller, getting smaller, getting smaller. Now I'm negative and I'm getting really negative. So it's decreasing the whole time. So if we put these two things together on this wavy curve here, we're going to highlight two colors for every portion. The first thing we're going to highlight is where the function is increasing and decreasing. So let's find the sections where this graph is increasing, meaning going up. I would say for me, it's kind of going up here in the middle, right? Do you agree? This is the going up portion. So let's take our green, and on the top of this graph, let's highlight the top part of it green, showing that this is an increasing portion of the graph. Increasing. The two little outside sections that we haven't highlighted green, do you see how they are going down and going down? Those two sections we would do pink because they are decreasing. That's the decreasing portion of the graph. So we've highlighted increasing, decreasing. At the same time, we can also find portions of this graph that are concave up and portions of the graph that are concave down. So y'all look at me for a second instead of the TV. Everybody do their hands like this. So I've got my wrists together, fingers up. This means concave up. Which portion of the graph, the first half or the second half, match this shape that your hands just made? The first portion. So that first portion, we're going to also highlight underneath it the blue concave up color. This is the section from negative pi to 0 that is concave up. You can kind of guess what concave down is going to look like. Show me with your hands. What would concave down look like with your hands? Yeah, not quite perfect because my elbows are in the way, but if your fingertips are touching and then they're coming back down here like little sad parabolas, this is the section that's concave down. So look at your graph. Do you see how that last half of it matches that shape? That's a concave down portion of this graph. So any curvy graph can be described with both its increasing and decreasing portions as well as its concavity. And do you see how there's like a mix and match going on? Right here, this first part of the graph, I have both pink and blue, and then it goes green and blue, and all of a sudden we're green and purple, and then pink and purple. So these words can mix and match. It's not just always increasing means up, as per usual. We actually need to look at the graph to see if it's increasing and decreasing, then if it's concave up and concave down. So let's practice one more time. With your hands, what does concave up look like? Okay, cool. Now with your hands, which side of this, your hands here, would be increasing? The right side, right? Because this one would be going down, this one would be going up. So this side of your hand is concave up and increasing. What would this one be called? Concave up and decreasing. Cool. Now show me concave down. Which side of concave down would be increasing? This one. Because it's going up, but it's still concave down. And so what would this one be called?
Concave down, decreasing.
Concave down and decreasing. This vocabulary is very confusing because it's so similar to each other. So we're wanting to make sure, I think the hands are the easiest way to think about it because it's right there in front of your face. Here's what a question might look like, is this one on the back. It is an important point that when we're describing features on a graph, we generally write the intervals where the graph displays those features. And when we're writing intervals, which you probably did in Algebra 2 class, intervals are the ones that are described with parentheses, maybe a U and a bracket. Do these things look familiar to you? Yeah, okay, that's interval notation. And we're going to use intervals here to describe the places on the graph where this is happening. And we're going to be looking at the x-axis for this to happen. So only choosing x value numbers to describe the graph. Probably before we start doing this, we should color code what's happening on this graph. So let's first go through with the same colors you used on the front for increasing and decreasing, and let's highlight this graph. So this first little portion right here, is this increasing or decreasing? Decreasing. So decreasing for me was pink, so I'm going to color this part decreasing. And then we have this like hump. What's happening on that little hump on this first side? It is totally concave down, but let's do increasing, decreasing first. Is this part increasing or decreasing? Increasing. So I'm going to grab my increasing color, which for me was green. But I don't go all the way around, even though you were right, it's all the way around would be concave down. Once it gets to that maximum right there, we start to decrease again, yes? So now I'm going to switch back to pink. Now I paused right here on purpose. This looks like a break in the graph, right? But is this part increasing or decreasing?
Decreasing.
Decreasing. So I have an actually pretty long decreasing section right here. It just has, it's called a piecewise function. You don't need to know that yet. I'll introduce that to you later. And then we turn the corner at 4 at that minimum, and what happens? We're increasing again. Okay, cool. So we have it color-coded right now for increasing and decreasing only. Let's also add concavity. Now this is a trick question. Would this section right here be concave up or concave down? Just this little sticky part. Does it look like this? Or does it look like this? It's curved? Your fingers are curved, right? It looks like this? Is it curved at all?
Oh, no.
So this is actually a really interesting moment. This one right here has no concavity. When there's a straight line, and this is why you never learned these words before, because this is a linear part of this graph, linear functions have no concavity because their average rate of change is constant. So it's not increasing and it's not decreasing. The rate of change is constant on a linear portion, which is pretty cool. But now my trick question is over. Nikila, you already saw this. This next little section, it looks like a circle. Is that concave up or concave down? Concave down. And it's the whole circular part is concave down. So I'm going to do this. I'm going to do that whole section purple because that whole section is concave down. But then we get to that weird moment we addressed earlier. It's still decreasing, but do you notice that it changes shape from looking like concave down to this one? Concave up. And that goes all the way around. So we have it color-coded. That's the toughest part, is making sure you're looking at the graph so that you can answer the correct question. Because here's the types of questions you may be asked about concavity. Part A says, which sections of this graph is H increasing? Well, what color for us was increasing, at least for me? That's green. So we're just trying to identify the green sections. This is the first green section right here. What x value does it start at? -2. And where does it end? 0. So it's increasing from -2 to 0. Is there another place where this function is increasing? Yes. Another green section exists starting where? At 4. And where does it end? I wrote a 5. That's so embarrassing. A 4. And where does it end? 7-ish. It's definitely not 6. We're going to assume that goes all the way to 7. We know what that U symbol in the middle means? Do you know what the word means? It starts with a U. You can say, I don't know. It's okay. It's called the union symbol. It's like the word and. Or actually, sorry, it's like the word or. So this or this is when it's happening. Okay, now H is decreasing. Now we need to do the other sections of this graph because we want to know now where it is decreasing. It starts decreasing at what number? -4, because we're doing input values. So from -4 up to what input value? -2. And where else is it decreasing? All the way to 4. Correct. Remember, we're always grabbing x values for intervals. Now we're switching. Now the question is asking for what intervals is h concave up? That's our blue section. How many blue sections do we have? Just 1. And where does it start? 2. And where does it end? Fabulous. Okay, the next one's very interesting because now we have a word and in here. We want to know where h is both increasing, that's green, and concave down, that's purple. So we're looking for where those two colors overlap. So increasing and concave down at the same time. Is there any section that is both green and purple? Yeah, where does it start? And where does it end? 0, very good. It doesn't go all the way around, right? Because that's the section that decreases on the other side of that little hump. We're just going from -2 to 0. Just this little part right here. From -2 to 0. Next question says, where is h both decreasing and concave up? So now we're looking for the other color combo of pink and blue. Is there any sections that's both pink and blue? What is the x value at which it starts? Ooh, I heard 2 different things here. 2 is correct. And where does it end? 4, right. We just want that decreasing portion. It is concave up all the way from 2 to 7. But remember, we want it to just be the decreasing part, so like just one hand of it. We saw this earlier. Where is it neither concave up nor concave down? Oops. Yeah, so we saw that. That's the linear portion. So not having concavity means that it's linear. That is going to be from -4 to -2. This important point that's listed next is actually like super duper important. We're not going to highlight the whole thing because that's obnoxious, but if you want to put like some stars next to this important point, this is very important. Essentially, rate of change means slope. So when I'm talking about concavity, I'm talking about concave up, meaning the rate of change is increasing, and concave down, meaning the rate of change is decreasing. I'm talking about the slope of 2 points on that line. Anytime we see the phrase rate of change in this course, we can generally replace it with the word slope. However, we need to make sure that you're reading carefully. This part we do highlight. Stating that f is increasing is very different than stating that the rate of change of f is increasing. So it's very important that from the beginning of this course, you start looking at what I'm asking you and how you're responding to me. Because you may be trying to tell me the right thing, but you use the wrong vocabulary, and that's going to be wrong. Part of this class is accurately describing mathematics correctly. So if you're trying to talk about the rate of change and you say the function does this, wrong. If you're trying to talk about the function and you say the rate of change, wrong. You have to make sure you're talking exactly about what you mean to in this course. So let's give it let me show you why this is so important. We're going to be looking at this graph right here and completing these sentences. We see this graph. Okay, cool. Let's describe it. This function is what? Is it positive or negative? Ooh, I already got you. Remember, the function is talking about the outputs. Are the outputs above 0 or below 0? Above 0. So this function is positive. So you can think of this as the outputs. That's a really weird word. Outputs. The outputs are positive. Is the function, are the outputs increasing or decreasing as we go along? Decreasing. This is what you were thinking of earlier. Which means, since the function is decreasing, we can also describe now the rate of change. Is this rate of change increasing or decreasing? Let me make it a more confident answer. Let's answer the second question first. Is this concave up or concave down? Concave up, which guess what? Which means it's increasing. These are tied together. Concave up graphs mean that the rate of change is increasing. Those are tied together. But you see how already right here that was so hard to answer? Yeah, we have to be so sure that we know what we're talking about here, whether we're talking about the function or the rate of change. Let's try it one more time now that we've seen all of the tricks. Here's the graph of g. Is the function g positive or negative? Negative, very good, because the outputs are below 0. Is the function g increasing or decreasing? Increasing, because it's going up. And maybe it's easier to answer the last one first. Is graph of G concave up or concave down? Down, because it would look like this if it was finished, right? It's this part of my hand. Concave down. I guess this one if you're looking at me. This one if I'm looking at it. Whatever, it doesn't matter. Which means that the rate of change is what? Very good. Okay, so those are tied together so well. It is so important that we make sure we know what I'm asking you about because it's so sturdy with those vocabulary words. So let's see what this might look like in an AP style question. There's a lot of words here, and I promise you it's not even that bad. It says, the graph of h of t and its dashed midline for 2 full cycles is shown. So we have this function h of t, and we have these coordinate points along the line. 5 points F, G, J, K, and P are labeled on the graph. No scale is indicated and no axes are present. The t-coordinate of F is t1 and the t-coordinate of G is t2. This has very crazy verbiage in it. This is actually from FRQ3, which you don't need to know yet. But with your highlighter right now, I don't care what color you use, I want you to highlight between F and G. Because this question is really only asking you about the function between F and G. We can ignore almost everything else. And let's describe the function in that interval between F and G. Looking at the output values, because remember the function H is describing the output values. Would you say that these output values are positive or negative? Were output values the first coordinate or the second coordinate? Are these output values? It's a second. The second coordinate points are my outputs. So if we're looking at the outputs here, we go from 4 to 0. Are those numbers positive or negative? They're positive. So I'm going to eliminate some answer choices here. H is not negative because those y values are positive numbers. So the function is positive. But here's the one you want to answer already. Is that section increasing or decreasing? That part's way easier. So if we eliminate the one that says increasing, we know the correct answer here is B. So let's remind ourselves what this means. We know that the y values for this graph are above 0, which means that we know it is positive. Y values are above 0 means H is positive. We also, using just some like casual language, we also know that the y values are going down, which means that H is decreasing. So you pay attention to the output values, the y values. The next sentence here on your CYU, and pretty much from here on out, I'm not going to give you the sentence stem, but I wanted to type a lot of it in for you so you saw exactly what I was saying. But this question says, on the interval from T1 to T2, which again is what we have highlighted, our interval from T1 to T2 is from F to G. It wants us to describe the concavity of the graph of H and determine whether the rate of change of H is increasing or decreasing. So the first question talked about the outputs. The second question is talking about the rate of change. So let's look. This section right here, would you say that this is concave up or concave down? Concave down. So let's write that in. The graph of H is concave down on the interval from T1 to T2. Therefore, since it's concave down, what does that mean for the rate of change? Is it increasing or decreasing? Decreasing. Down means decreasing. That sentence right there won't be fill in the blank for you from here on out. It doesn't have to be perfect, but I need you to answer the question. The question has the sentence stem in it. Describe the concavity of the graph of H. The graph of H is concave down. You see how I took basically the question, rewrote it, and answered the question? And here's my second sentence. Determine whether the rate of change is increasing or decreasing. The rate of change of H is decreasing. We answer the question. You don't have to memorize anything, it's in the question. You do have to rewrite it because they were writing me a sentence answer. You will see this from now until May, this particular sentence. Questions, comments, concerns? One last check. Show me concave up with your hands. Show me which side is increasing. Which side is decreasing? Okay, show me concave down. Decreasing? And increasing. Okay, we got it. I'm not worried.